Lesson 13 is about radian measure, and in 13.1 we're going to introduce what a radian is. So before you watch this video, you should have already watched the what is a radian video that is posted in Canvas. So if you haven't yet, make sure you go back and watch it. It should be on the same page as this video. So before we get started in finding these angles that are drawn into the circle, in the upper right section there's a few important notes. It is standard form of an angle. So standard form of an angle has the initial side starting on the positive x-axis, and the terminal side is the name of wherever the angle opens up to. So for example, let's say this is about 135-degree angle. However far it opens up, that second ray that kind of creates the last edge of the angle is going to be called the terminal side. And then now angles can have a positive and a negative measurement. So you could have a positive 90-degree angle or a negative. The way that you tell is the direction that they open. So if an angle opens counterclockwise, they would have a positive angle measurement. I know that feels kind of counterintuitive, but just like how this angle opens counterclockwise, it's going to have a positive angle measurement. And if it opens clockwise, it would have a negative angle measurement. Okay, so in 13.1, we're going to label not each point, but these two angles. Sorry, I meant to erase these two angles within the circle in radians. So you should have learned from the video that if you do one full rotation around the circle, it's 360 degrees when it comes to degrees, but in radians, it's 2 pi. So if we're starting at the initial side, it would be at 0, and then after one full rotation, that angle would be at 2 pi. So if it starts here, rotates all the way around and kind of lands back at itself, it's done one full rotation and it would be at 2 pi. So knowing that one full rotation is helpful to figure out what the little increments are inside. So if you think about if I do one full rotation, it's 2 pi. So if I did half a rotation, this would be just pi. And the rest of it is just kind of equal increments or slices of the pie depending on what point you're looking at. So what I mean by that is if let's say this is where we're starting, this is the halfway point, this would be a fourth of the way, because it's half of half, and then this would be 3/4 of the way around the circle. So this is 1/4, 2/4, 3/4, 4/4. So if this point right here, N, is 3/4 of one full rotation, you can take 3/4 and you can multiply it by one full rotation, which is 2 pi. So it'd be 3 times 2 pi is 6 pi over 4. And then 6 pi over 4 reduces down to 3/2. So that angle that opens up to point N would be 3 pi over 2. You can also think of it in terms of okay, well, it's halfway between 1 pi and 2 pi, and halfway between 1 and 2 is 1.5, but we wouldn't write 1.5 pi. We would write it as a improper fraction, which is 3 pi over 2. And then if we move on to that pink angle, we think of what the slices are that are that big. So we're starting right here on the initial side. I have a slice right here. If I kind of create another slice that same size, and I keep creating slices that are that same size all the way around the circle, I would have 1, 2, 3, 4, 5, 6, 7, 8 of those identical slice pieces. So that means that that point at D is 1/8 of a full rotation. So we could take 1/8 and multiply it by 2 pi, and that would be 2 pi over 8. And then if we reduce that, that would be pi over 4. So that angle that goes to point D is pi over 4. And you can also approach it as if you're just looking at between 0 and 1 pi. So if we look between 0 and 1 pi, then there's 1, 2, 3, 4 slices, and that's the first slice out of the 4 between 0 and 1, so 1/4 pi. Moving down to 13.2, in this section, we're going to learn how to convert between radians and degrees. If you are given degrees and you would like to convert them to radians, you're going to take the degree number and you're going to multiply it by pi over 180. If you want to do the reverse of that, if you want to start with radians and you want to convert it to degrees, you're going to take the radians and you're going to multiply it by the reciprocal, which is 180 over pi. So these are something like you would definitely want to save them and keep them handy for like checkpoints and exams. So example 1, convert each angle from degrees to radians. So since we're trying to go to radians, we're going to take our degree number and we're going to multiply them by pi over 180 degrees. So we'll take 90 and we'll multiply by pi over 180 degrees. It's kind of like when you need to convert units in like chemistry, and you have to kind of cancel out the units you no longer need. Like in this case, we're trying to get rid of the degrees and go to radians. So you have the 180 degrees in the denominator so that the degree symbols are going to cross cancel each other. Okay, there's usually more things than just that will cross cancel though. So like the 90 and the 180 we can cross cancel and we can divide them both by 90. So 90 divided by 90 or 90 degrees divided by 90 degrees would just become 1 and the degree unit would cancel out. That's kind of small, sorry. And then 180 degrees divided by 90 degrees would be 2. And then now we can multiply straight across. If you would like to see it as like 90 degrees over 1 to multiply straight across, that's fine. But it would be like 1 times pi, which is pi, over 1 times 2 left over in the denominator. So it'd end up being pi over 2. So pi over 2 is equivalent to 90 degrees. Pi over 2 is just the measurement in radians. And then for 120, same thing, we're starting with degrees. We want to convert to radians, so we're going to multiply by pi over 180 degrees. I can divide both 120 degrees and 180 degrees by 60 degrees. So 120 divided by 60 would become just 2, and then 180 divided by 60 would become just 3. And then now I can multiply straight across. If you want to think of this as like 120 over 1, you can. But it would be like 2 times pi, which is 2 pi. And then in the denominator, 1 times 3, which is 3. So it'd end up being 2 pi over 3 is equivalent to 90 degrees. 2 pi over 3 is the radian measure. And then for 75 degrees, same thing, we want to convert to radians, so we'll multiply by pi over 180 degrees. Any number that ends in like a 5 or a 0 is divisible by 5, so I'm just going to start by dividing both by 5 and see where that gets me. So 75 divided by 5 is 15, and then 180 divided by 5 is 36. And then, of course, like the degree symbols also cancel out, so I have the 15 and the 36. And now, for 15 and 36, they're both like divisible by 3, so we can reduce a little bit more. So if I, let's say, divide 15 by 3, that would become a 5. And then 36 divided by 3 would become a 12. So equals... left over in the numerator, I have 5 times pi, so 5 pi. And then in the denominator, I have just 12 left over, so it'd be 5 pi over 12. Okay, so you don't have to figure out like what the greatest common factor is at the very first step. You just have to make sure that you keep reducing until you no longer can. Example 2, convert each angle from radians to degrees. So this time we're going to take our radian measure and we're going to multiply it by 180 over pi. So I have like pi over 6. I need to multiply that by 180 degrees over pi. And just like in the previous example, we were trying to cancel out the degree measurement. In this one, we want to cancel out the pi most of the time. It doesn't always happen, but the majority of the time it will. Okay, so the pi's, we can cross cancel those because there's one in the numerator and one in the denominator. And then we don't want the degree symbol to cancel out because we're trying to convert to degrees. And now we can look at the 6 and the 180, and they're both divisible by 6. So 6 would become 1, and 180 would become 30 degrees. So now I can multiply straight across. This just becomes like 1 and 1. So left over, I have 1 times 30 degrees is 30 degrees. And then in the denominator, 1 times 1 is just 1, so I don't need to put that denominator there. I just leave it at 30 degrees. And then for B, so it's 4 pi over 3. So we're starting with radians. We want to convert it to degrees again. So we're going to multiply by 180 over pi, 180 degrees over pi. Same thing here, we can cross cancel the pi's because they have one in the numerator and one in the denominator. And then for the 180 and the 3, we can cross cancel those. They're both divisible by 3. So the 3 would become a 1 and the 180 would become a 60. So left over, I have to multiply 4 times 60. So 4 times 60 is 240 degrees. And there's nothing left over in the denominator. So we just leave it at 240 degrees. And then the last one for C, it's 7 pi over 4. So we're going to take that 7 pi over 4 and multiply it by 180 degrees over pi to convert to radians. So we can cross cancel the pi's again. 180, I think is divisible by 4. I think it's 45. Yeah, it's 45, so we can cross cancel the 4 and the 180. The 4 would become a 1, and the 180 would become a 45 degrees. And then now we need to multiply the 7 and the 45 together, and that would give me 315 degrees. So 7 pi over 4 converted to degrees would be 315 degrees. Okay, moving down to 13.3. 13.3 is about coterminal angles. So coterminal angles are angles that stop in the same place, but they have a different measurement. So for example, imagine if you're looking at an analog clock and it says 6 o'clock. If the clock has only rotated like half of the way around the clock since midnight, then it's 6 a.m. So for example, like I have a clock, up here is like 12 and down here is 6. So if it hits midnight and it's only gone halfway across, then it's 6 a.m. But if it's made 1.5 rotations, so if it like continued from like there and went one extra like kind of full rotation, so like from midnight it went 1.5 way around, it'd be 6 p.m. So like when the like hour sign is at the 6, that would be like a coterminal angle with 6 a.m. and 6 p.m. Meaning they stop in the same spot, like it looks the same on the clock, but they tell you 2 different times. Okay, so to find coterminal angles, when you're finding a coterminal angle of something in degrees, you need to add a full rotation, and there's 360 degrees in a circle. So you're going to add or subtract 360 degrees, again, for when it's in degrees, and then when it's in radians, you're still adding 1 full rotation. But for radians, 1 full rotation is 2 pi. So you'd add 2 pi, add or subtract 2 pi. Okay, example 3, find 3 positive and 3 negative angles that are coterminal with 30 degrees. So 30 degrees is like kind of drawn on there. If I want to find something that's coterminal and positive, I would need to take that 30 degrees and I would need to add 360. And if I need to find 3 of each, I'm going to have to do that more than once. So if I take 30 and I add 360, that's going to give me 390. So that's one of them. But if I want to find another positive, I need to add 360 again. So I'm going to take that like 390 and I'm going to add 360 again. So 360 plus 390, or 390 plus 360 is 750. So 750 would be another coterminal angle with 30 degrees. And then we're supposed to find 3, so I would have to go another full rotation around and add 360 again. So 750 plus 360 is 1,110. So 1,110 degrees. So now we have 1, 2, 3 angles that are all coterminal with 30 degrees and positive. Those are all the ones in green. So anytime you want to find a coterminal angle, you're adding or subtracting 360 depending on if you need a positive or a negative answer. But what that means is that 390 degrees, 750 degrees, and 1,110 degrees all stop in the same spot. Okay, and then if we need something that's negative, I need to go backwards. So instead of so if I'm going backwards, it would be like subtracting 1 rotation off. So I would be subtracting 360 degrees instead of adding it. So for negative, it'd be 30 degrees minus 360 degrees, and that would be negative 330 degrees. One kind of common, I'm going to move this over actually. One kind of common mistake that I see with a problem like this is people will want to take 360 and subtract 30 and they get a different answer, but we always have to start with the angle measurement. So start with whatever angle you're trying to find something that's coterminal to. Don't start with the 360. So 30 minus 360 is negative 330, so that's going to be one of the angles that's coterminal. It'll be one of the negative ones. And then we just have to keep subtracting 360 to continue to find more negative ones. So it'd be negative 330, and then minus 360 is negative 690. So negative 690 degrees, that's going to be our second negative coterminal. And then we need to just subtract 360 again. So we'll do minus 360 degrees again. And then it'll end up being negative 1,050 degrees. So we have 3 positive and 3 negative angles that are coterminal. The 3 green ones are all of our positive ones. The 3 red ones are all of our negative ones. Okay, example 2, find pretty much the same problem, but we're going to find it in radians. So find 3 positive and 3 negative angles that are coterminal with 2 pi over 3. So kind of the idea is the same. We're going to have to add or subtract 1 full rotation. If I start here and I go 1 full rotation around, that would be 2 pi in terms of radians. However, we're going to be adding that 2 pi to 2 pi over 3. So we're adding fractions, so we need to get a common denominator. So whatever your original angle is, you need to match that denominator. So our denominator is 3. So what we're going to do is we're going to take 2 pi over 3, or not 2 pi over 3. We're going to take 2 pi because that's 1 full rotation. And we want to take that 1 full rotation and we want it to convert it to something that has the same denominator as our actual angle. So we would take 2 pi and multiply it by 3 over 3. We can think of this as 2 pi over 1. So 2 pi times 3 is 6 pi over 3. So now this is equivalent to 2 pi, it's the same value because 6 over 3 is 2. It just now has the same denominator as our original angle, and we're going to have to add or subtract it from our original angle. So we're going to use that 6 pi over 3 instead of 2 pi, when we're trying to find the full rotation. So for my positive one, we're going to start with our original angle, so 2 pi over 3. And then we're going to add 6 pi over 3. And when we add fractions, we just add the numerators. So that would be 2 pi plus 6 pi would be 8 pi over 3. So that would be our first coterminal angle. And then we're just going to keep adding that 6 pi over 3 because that's what was equivalent to 2 pi. And this part will change very much depending on what your original angle is. So it won't always be 6 pi over 3. It'll always be like some variation of 2 pi, just like with the same denominator as your original angle. So like if your original angle has like a denominator of 4, it would be 8 pi over 4. Or if it was like 6, it would be like 6 pi over 4, and so on. So now I have to take that 8 pi over 3, and I have to add 6 pi over 3 again. So same thing, you just add the numerators. So like 8 plus 6 is 14 pi over 3, so that'll be our second one. And then we're going to add 6 pi over 3 again. So 14 plus 6 is 20 pi over 3. And like the denominator is not staying the entire, or not changing the entire time, we're just changing the numerator by adding 6 pi to it. So 2 pi plus 6 pi is 8 pi, 8 pi plus 14 pi, or 8 pi plus 6 pi is 14 pi, and then 14 pi plus 6 pi is 20 pi. And then for the negative, it's the same idea, we're just subtracting, so we'll do 2 pi, and then over 3 minus 6 pi over 3. So 2 pi over 3 minus 6 pi over 3, 2 minus 6 is negative 4 pi over 3. So that's our first negative coterminal angle. And then we'll just keep subtracting 6 pi over 3. So minus 6 pi over 3. So I just subtract the numerators. Negative 4 minus 6 is negative 10 pi over 3. So that's our second negative coterminal angle. And then I need to subtract 6 pi over 3 again. So negative 10 minus 6 pi is negative 16 pi over 3. So that's our last one. So for when it's in radians, you're adding or subtracting 2 pi, but you have to change it first so that it has a common denominator. So this step should always come first for a problem like this when it's in radians.